model fitting, things like that. So you can try to read all about this torch add-in. It will save you quite a lot of time. If you hit some of the kind of scenario, right, then what you want to do with it, right? For example, tune the model so that the validation curve decreases and stay flat in a steady minimum. If it's still declining, yeah, you increase the epoch, or you want to also maybe increase the learning rate so they can go faster, right, to hit to this local or global minimum. Okay, so let's see. We go down. We have this actual by predicted plots, which is something very useful. You can have ideas of how good this model is working. It seems like it's not really well, especially on the tail side. So you can then say, I want to know what happened for this one, and select it. This is where jump become very powerful because you are literally maximizing your deep learning this application on the current offering of jump, whereby I can dynamically select these outliers. When I select them, I can see I have 22 right in the table. I can quickly jump into it, look at the data. What happened to all this data, which is OS, what log ID, and what is this maybe thickness, roughness range. I can even also try to look at which chamber, is there any common chamber, right? I also built something to further showcase to you why the dynamic linking is so useful, right? So I can build a graph builder. Then I can pull in all my factors. Right, then I have all this, right? So this selection that I have, I want to go back to select the outliers. Can be anything, right? It can be something over here and this one. I select all this, then you see it's linking, right? In jump in my visualization. I can change that to these parallel plots, right? Then you can see the one that I'm selecting below you, where are they passing by in terms of the process step or process 2. Okay, this is a bit random. More of them going through the current at the lower side. Okay, so this is very powerful, this visual for you to have this dynamic linkage to build connection with the data while you're evaluating your model. This one will be all about how many parameters you build in, like 273 is not a lot. If you play with this image model, right, then you will have a few 100,000, few millions or more than that. And this model is much better. You can see now it's all sitting here, right? This is much better. I can also take a look on this tree. What happened to this tree? I just want to drill down and zoom in and take a look. Maybe these all are here, and it seems like they are. Oh, just minimize that so that it's clearer. They are having missing data in this current data set. So you might want to also check. Let's say I'm looking at I'm drilling down to see if there's any commonality. It seems like they are all having missing current. Can it be because of the lots having problem, or these two, when it's run at this some of the process step, then it's not being tracked out properly. That's why the number is not there. So these are the things that will link back you to the operation of this manufacturing of the wafers. Then you can have some ideas of maybe this is the direction, maybe because of missing of this current, right? And all of them can be impacted. It can be some tool issue. So if I have that in mind, maybe I can then just look at all the missing current, and I can come back to here to take a look if it's true or not in terms of the how it run in from steps to steps. I can also look at this, right, in my diagram of validation. Seems like most of them are in this region, right? It can be true as well. Maybe you want to check what happened that can cause the missing data of current. Is it because of error alarms during the processing or things like that? Okay, so this is about this data set, and we have a bit time left. I need to move in to another area. Maybe I should show you also. I will show you how you can save the model, and then you can how you restore that and how you can deploy that. All right. So in this area, right, you can see we have this folder. I can go to the folder. Maybe I open a new one. Okay, so you see that I have some model previously I saved, and I can go back to this diagram. Oh, where is it? Yeah. So this one, maybe I just want to scrap it, right? I can just unshow it. Then it will just show me the second one. So this is for you to toggle what to show, what not to show. And I can also try to remove that. I just want to remove the hidden model. They will remove from this comparison box so that you don't need that, because sometimes you might fit the law, right? Then you want to just remove those that's not useful one. And you just retain the few top few, right? And you can try to have also the this setting, how it was being set up. And then I can save it. Oh, this is just to show you, you can toggle to see what you want to see. Root square error, absolute errors, things like that. And if I go to my model too, I can save the model and call my model. Click OK. Here is right. So it's 145. I run at 145. When you go in, we have this PyTorch file. Right? You have these three for each of the validation, because you recall we split 3 times 5, right? So you have each of this validation part, you have 5 of them, and each of them have 3 different PyTorch file. It's actually an embedding file. One is to record the setting that we put for the model. One is to record the embedding parts or the deep neural part, and then the last one will be the classifier part. Okay, so these are the things that you can, if you want to deploy it, you can pass this to the IT team or the analytics team that they want to deploy this in real time, PyTorch. You can also load that back in. If you are here, right, you train halfway, maybe you want to continue, you can then try to find here, my model, and then you just set up anything that you need. Then you click on go, then you just restore from this my model. Okay. Of course, you will ask why jump, right? It's a tool for you. It's a tool for scientists, engineer, and for any organization that rely on this for discovery. And we are actually now lowering the barrier of AI application in Jump. You don't need any coding. You can get more investment from your Jump Pro. You can deliver robust products and processes that will work. And of course, you will improve the engineering efficiency, right? You get insight faster, you get home earlier, you accelerate the innovation, speed up time to market. These are all the key KPI for any of the company, and increase the growth and return, build and advance. I think this culture, we hear more than we see people doing, right? So now you can actually just carry out that task in Jump, drive data and AI literacy throughout your organization, make AI modeling visual and approachable, right? So before I end this today's webinar, I would like to also quote our founder, Jump founder. He says that statistical power insights leads to discovery. Discovery will change the world, right? And of course, one of the key things, this yielded one question of the day to all of us. How do you plan to initiate a change today? Sometimes it might seem to be quite daunting, right? But at times when we look closer, maybe the answer is just in front of us. Okay, so with that, I would like to end today's webinar. Thank you.